Immunotherapy and unlocking the cure to cancer.
So, what is immunotherapy?
Immunotherapy is essentially training your immune system to fight cancer better and smarter. Think of it this way. Cancer is a criminal and your immune system is a security system. This security system helps protect your body against the adverse effects of cancer. But before we delve into immunotherapy, let's talk about cancer. Cancer cells are formed when a mutation occurs in a normal cell's DNA. This mutation allows cancer cells to ignore the signals from the body that tell them when to die. Because of this, cancer cells will grow uncontrollably and form tumors. These tumors will not function with the rest of the body since these cancer cells have lost their ability to perform their primary function. Here we have a box that represents the body and a circle that represents a healthy cell. Next, we have the introduction of a cancerous cell into the body. As you can see, the cancerous cells reproduce much quicker than the healthy cells and start to overcrowd and take over the body. Normal cells will die off when they become damaged or grow old. Cancerous cells, on the other hand, will not. They will continue to grow uncontrollably and will not die or perform their primary function. In addition to overcrowding the body, cancerous cells will also take away nutrients from the healthy cells. Now let's get to the good guys, the immune system and the T cells. They use something called an immune checkpoint to help detect and kill cancer cells. T cells are a type of white blood cell that kill cancer cells and other things that can harm the body. They hunt down any cells that have been infected by bacteria or have become cancerous. They can recognize cancerous cells using their outer layer and antigens. So, if T cells can kill cancer cells, how come people are still getting cancer? The answer to that is that some cancer cells have mutated to avoid T cells. How? Cancer cells can use the PD1/PDL1 pathway to deactivate T cells and to pretend that they are normal cells. In simpler terms, it's like a disguise. T cells use receptors to detect antigens on the outside of cells. If they find that the antigen fits, they will not destroy it and recognize it as a healthy cell. If the antigen does not fit, then the T cell can kill and destroy the foreign invader. It's similar to puzzle pieces or Velcro. These sneaky cancer cells can connect to the T cell's PD1 and PDL1 receptors. PD1 is a protein found on T cells. It connects to a ligand called PDL1 to signal the T cell not to attack. PDL1 is found on some normal cells and on some cancer cells. How pembrolizumab, also known as Keytruda, fixes this problem and helps the T cells. Pembrolizumab is an injection into the veins that blocks cancer cells from connecting with T cells with their PDL1. It sends a protein to block the T cell's PD1 receptor so it cannot connect with cancerous cells' PDL1 and will be able to kill and detect cancer cells once again. This essentially means that cancer cells can no longer trick T cells. The future of immunotherapy looks bright, and it has now moved to the forefront of cancer research. In 2017, more than 250 immunotherapy medications and vaccines were in development. Scientists are looking to develop new solutions to cancer and to be able to control tumors by both blocking T cell receptors and bioengineering T cells to redetect cancers.